So this one is super interesting example. Pay attention. Let's quickly get started with this one. So this is minimize the objective function given to you. Subject to these constraints, there are these three constraints given to you and then the non-negative constraints. Okay, and you have to solve this LPP by using graphical method. So for that, how do we start? In the beginning, we remove the inequality signs from the constraints and just keep the equality signs and then find out the coordinates to form a line. Okay, so let's take the first constraint. So that is what? 5x1 greater than or equal to x2. x2 is on the right hand side. Let's take that on the left hand side. So that is nothing but what? 5x1. This plus comes here. So that becomes minus x2 greater than or equal to 0. As nothing is there on the right hand side right now. Correct? So let's remove this inequality sign and just keep this sign. Okay. So this is my equation number 1. Okay, now I cannot, as on the right hand side it is 0 now, I cannot do with my shortcut trick right now here that dividing whatever is there on the right hand side to the complete equation so that I get 1. I am never going to get 1 on the right hand side, right, because it is 0 already. So let's go with the traditional method. Okay, so putting x1 as 0 to get x2 and then putting x2 as 0 to get x1. So if you observe and put x1 as 0, you can straightway say that x2 also is 0, correct? If you put x2 as 0, same way you get x1 also 0, because on the right hand side it is 0. Okay, so whenever you see this right hand side as 0, you can say that one of the coordinate is nothing but 0 and 0, which is nothing but what? Origin. Okay, so this line is basically passing through the origin, but then say this is the origin, right? But then it is passing through origin, but is it going this way or this or this or this? You don't know, right? So you have to find out one more coordinate to understand what is the line, right? Say you get the other one coordinate is this. Say you get the other coordinate here somewhere, then you know the exact line, correct? So find out the next coordinate for this equation 1. How you can find it out? Put any number in place of x1 or x2 and find out the remaining one. So let's assume I am putting 2 in place of x1. You can put anything, okay? And then you can find out the value of x2. So that gives me what? If you take x2 there, so that gives me 10, right? So I get the other coordinate as what? When I put x1 as 2, the x2 is 10. Yes? So these are the two coordinates which are there for equation number 1. Clear? Understand this, okay? This is something different than the traditional constraints. Now the second constraint. Second is what? x1 plus x2 is less than or equal to 5. So let's remove that less than and keep this 5 as it is. So this is my equation number. Keep this equal to as it is and this is my equation number 2. Okay? So now let's divide with this 2 to both the sides and that gives me what? x1 by 5. x2 by 5 equals to 1. Means what are the coordinates now? A up to A is done, right? So I get B and C here. What is B? 5 and 0. And what is C? 0 and 5. Easy? Very easy. Now let's go to the next line. Okay, now see carefully. We remove the inequality sign and just keep the equality sign. But already it is equality sign only in the example given. So the same thing we are going to just copy and this is my equation number 3. Let's do the same thing. Divide by 9 to the complete equation. That gives me what? x1 divided by this 9 here divided by 9 means 3 3s are 9 plus x2 by 9 equals to 1. So this gives me the next two coordinates which are D and E. So what is D? 3 and 0 and what is E? 0 and 9. Okay, so you got the coordinates for all of these three equations and fourth is your non-negative constraints. Okay, so that is fine. Okay, so now let's plot these points on the graph. 2, 4, 6, 8, 10, 12. Okay, 2, 4, 6, 8, 10. I recommend in the exam on the graph paper, if it allows, I mean if graph paper allows you and time allows you, take the gap as small as possible basically for the accuracy purpose. Means you can take it 1, 2, 3, 4 also. Okay, it will go up to 10, 12, but then still it is fine. It is going to give you the more accurate results. Okay, on the graph paper itself. Okay, now let's start plotting the this on the graph paper. So first is what? O is there. Now A is what? 2 and 10. So 2 on the x-axis and 10 on the y-axis. Okay. So where this A point is going to come? Here, right? So this is nothing but this 2 on the x-axis and 10 on the y-axis, correct? This is my point A, 2, 10, okay? I'll just remove these dots which I have shown you for explanation purpose. Okay, so this is my line number and which is passing through this origin, correct? So let me draw this line here. So this is line number 1, okay? This is equation 1. This is equation 1. Now equation 2 says 0, 5, 5, 0, okay? So 5 on both the axes. So here it is B and here it is C, okay? On B it is 5, 0 and on C it is 0, 5, okay? Now let's connect these two coordinates. This is your line number 2, yes? Line number 3 is what? 3, 0 and 0, 9. 3, 0 means here, correct? So this is what D point. Point D is 3, 0 and 0, 9. 0, 9 is going here, correct? This is what E. E is your 0, 9. So let's connect these 2 points D and E to form a line, okay? So this is my line number 3. Okay, so this is how these 3 lines are formed. Now, as you already know, you have to check for what? You have to check for feasibility region. Okay, I am drawing it little nicer. Okay. So, for the first equation, now pay attention carefully. If it is greater than, then away from origin. If it is less than, then it is towards origin, right? But it is already passing through the origin. You getting my point? So, you don't know which is going to be the region, feasible region, either the right side or the left side, correct? So, basically there are 2 sides to this line, either this side or this side. What you have to do for that, pay attention here. You have to take any coordinate from this right hand side one time and put that in your this equation 1 and see if it violates the constraint or no. Again next time check the other side, left hand side, take any coordinate from the left hand side, again put it in that equation and check if it violates the constraint or no. So let's do it quickly. So for this line on the right hand side, this complete is the right hand side, right? So I can take this constraint, this coordinate like 2 and 0. Okay, so let's take 2 and 0 coordinate, 2 and 0 coordinate. I put it in this equation. So if I put 2 and 0 here, it gives me what? 5 into 2 minus this 0. That gives me what? 10, correct? And is it greater than or equal to 0? Yes, this is valid. This is true, correct? Now let's take one more coordinate from the left hand side of that line, because the line is passing through origin itself, right? So you have to decide the feasibility region if it is from the right side or the left side. So it is definitely going to be the right side region. Why? Because it validates your constraint. It does not violates that constraint. And now let's take any coordinate from the left hand side and check like if that is also the valid condition or no. So I can take this 0, 2, correct? So if I take this 0, 2 point here and put it in this equation, so that is what? 5 into 0 minus this x2. So that is what? Minus 2. So it has to be greater than or equal to 0. Is it greater than or equal to 0? No. So this violates the condition, meaning that the right hand side of this line is a valid region or feasible region, you can say, but the left hand side region is not the correct one. So this is going to be in this direction, right side direction. Done with the line number 1. This was the only complex part in this example. Now let's go to the line number 2. Line number 2, it is like very easy. So line 2 is less than or equal to straightway, less than or equal to means towards the origin. So this line 2 is going to be towards the origin. Yes, this way. And then line number 3. See now this is again one more tricky part in this example. So this is equal to, this is not less than, this is not greater than. So this is not moving towards the origin or away from the origin. It is on the line itself. You getting my point? Because this is the line, this is the equation 3, right? This line is only the feasible region. So now what is the feasible region? If you see now, this line is moving towards right, this is moving down, and this is the only feasible region for line number 3. So this part which is there, only this much part I can say is the feasible region, considering combined region of all the 3 lines, right? So this is the only feasible region you see here. So this one coordinate you already know, 3, 0, right? That is what? D. You have marked it as D, and next coordinate you can call it as F because till E it is done, right? I would mark this coordinate as F. So you got the feasible region. How did I figure it out? See now, I would explain one more time. So this is line number 1. Okay, this is already passing through origin. Okay, so you don't know like if it is towards origin and away from origin. How are you going to identify that, right? So you have to take two coordinates, one from right side and one from left side, and put it in the constraint and check if that violates the constraint. If it violates, then no, that is not the region you are going to mark. Okay, and if it validates the constraint, or then in that case, yes, you will consider that region. Equation 2 was comparatively easy. You didn't have much of a trick in it. So it was simply this way, and it is less than or equal to, so it is moving towards origin. In third equation, it is just equal to, so it is not moving away from origin or towards origin. It is on the line itself. So this line is the only feasible region, but then not this complete line, correct? Because the other two equations are also there. So considering these all three equations, only this part, only from this to this is your feasible region. So now you have to find out the, as we always do, we find out the coordinates of the feasible region. So the feasible region here is D and F, correct? So you have to find out the coordinates of both of them. D you already know, it is 3, 0, and F is what? Intersection of which two lines? This line number 3 and this line number 2. So what are these 2 and 3? 2 is here, 3 is here. If you solve these two equations parallelly, you get the values of x1 and x2. Those are nothing but your coordinates. Okay. So this is what 3x1 plus x2 equals to 9. Okay. I do it here. Okay. 3x1 plus x2 equals to 9. And what is 2? x1 plus x2 equals to 5. x1 plus x2 equals to 5. Subtract these two. So minus, minus, minus. So these x2 will go. What is the x1? 2x1 equals to 9 minus 5 is 4. So value of x1 is 2 here. Now put this 2 in this equation and you get the value of x2. So what is that? 5 minus 2 is 3. So you got that x1 and x2 as 2 and 3. So what is the coordinate F? 2 and 3. Okay, you got these two coordinates. D is what? D is 3, 0. So D is 3, 0 and F is 2, 3. Now the same way, you are going to put those two values in Z, that is in objective function. So basically there are going to be ZB and ZF, correct? So what is the objective function? x1 plus 4x2. So this x1 plus this 4x2. This x1 plus this 4x2, correct? What for B the values are 3 and 0, and for F the values are 2 and 3. So this is going to be 3 and this is going to be 12 plus 2, 14, correct? Now what is the question? It is of minimization, correct? Means the objective function is to minimize this. Whichever is the smaller value is your answer. What's the smaller value? That is 3, correct? So you can say that in the conclusion part of this problem that the ZD equals to 3 at point 3 and 0 will give the optimum solution for this given LPP by using graphical method. So I hope you like this video. This was very tricky and something different than the regular LPP problems. So yeah, if you like it, please like, share and subscribe to my channel. Keep sharing, keep studying and share this video with the students who are preparing for various exams and whose exam is approaching and who really wants to learn the LPP. Okay. So yeah, see you in the next video. Till then, keep studying. Bye-bye.